Yeah, cameras are always going to be the richest source of information. They are rich in terms of what they can provide as far as total in-cabin solution. However, there are always going to be challenges, for example, occlusions or a baby covered with a blanket. And so this is where we think of complementary solutions to image sensors such as radar, thermal imagers, in order to augment the accuracy of the features or the analytics, as well as to provide additional redundancy for safety critical features. Of course, anytime you talk about multiple sensors, it's a lot more data. It's data management. It's also processing hardware or processing power, keeping thermal controls in place, or power in terms of, in other words, keeping the power, processing power also under control, generally under 5 watts. It's what's accepted by OEMs and Tier 1s. But other than that, the benefits far outweigh the challenges for the multi-sensor fusion. And we've seen this with external perception. There is LiDAR, radar, cameras, sonar, and other sensors on the external of the vehicle in order to cover as many things as possible and cover as many corner cases as possible. We expect the same thing to happen inside the cabin. In fact, this is the reason why we introduced the world's first in-cabin sensor fusion AI at CES 2 years ago. Yeah, so historically anything that's ever been done inside the cabin has been in 2D or with 2D cameras. There has been some implementations using 3D cameras like time-of-flight cameras or even stereo cameras, but there are challenges to those, such as cost or interference with other cameras, and also technology limitations, resolution, and things like that. For the last couple of years, we worked on Monocular 3D because we thought it would be extremely helpful, and we thought it would be extremely helpful to OEMs and Tier 1s, because for the first time we introduced depth-aware information instead of just information that says this is a bounding box for the face or the body, this is the eye tracking or the eye gaze vector. We add an additional dimension, which is the depth information in this case. So for the first time ever, using a standard 2D camera, typically an RGB-IR sensor, the OEM or a Tier 1 is able to identify and understand what's the distance between any region of interest relative to the camera or relative to any other point within the vehicle. Very, very important for human-to-human interaction, human-object interaction, as well as human surface interaction. We see a lot of new use cases. Lowest hanging fruits is dynamic airbag deployment. In other words, airbags that understand the body height, width, size, posture, orientation, distance relative to any surface within the vehicle. We also talk and have been talking for a while now about 3D scene reconstruction. In other words, the vehicle will understand what happened or reconstruct information about what happened before an accident occurred, during an accident, and even afterwards. It's really the combination of everything you've just mentioned. So it's our innovation. We keep pushing the envelope every single time and every single year. We've announced multiple world's firsts over the last few years. It is also our collaboration with our hardware partners, from image sensor companies to AI chip companies. We try to facilitate the task for OEMs and Tier 1s to take an all-in-one solution that's readily available and run away with it for production. And so this is really what's probably been raising eyebrows and why the industry has been recognizing us for the last few years as one of the leaders in in-cabin space.